So this is Dilemma. Let's get started. Founding a software startup is hard. Building an application in Java 2 Enterprise Edition is hard. Building a server, going down to a data center, wiring it in to serve production traffic is hard. And then going home and configuring thousands and thousands of lines of XML to build your Tomcat server to actually go to production is a nightmare. If I walked into a venture capitalist's office in 2017 and told them this was my strategy to found a new software startup, I would most likely be laughed out of the room. We spent years building platform as a service startups like Heroku and infrastructure as a service startups like DigitalOcean to ensure that never again does a developer have to go to a data center to serve production traffic. We spent years building frameworks like Ruby on Rails and Django to ensure that never again does a developer have to pop open an XML file and write thousands and thousands of lines of code just to get their application to boot. But in the year 2000, if I told you that's how I was going to build a new software system, you would believe me. That's a reasonable position for me to take. You have to remember, this is a time when adverts like "nobody ever got fired for buying IBM" were prevalent, and people actually believed them. And in 2017, it's easy to laugh at the kind of mistakes that we were making back then, but the truth is these are really, really smart people. Some of them are probably in this room. There are people who built Java enterprise applications in this room. And at the time, you have to remember, there really wasn't an internet. We were only 5 years into the World Wide Web. And these people were working incredibly hard on complicated problems, basically inventing new solutions that enable the newer, younger programmers in this room, like myself, to actually do their jobs. And that didn't come without rewards. Some of them are now richer than any of us could possibly imagine. The point is this. In software engineering, the context in which you work changes. Over time, the way the industry functions, the trends that we have, the software that we build, the way we push code to production, it all changes all the time. And the mark of a really great software engineer and the mark of a really great programming community is having some ability to change with the changing context of the world around us. So let's bring this idea to Ruby. What are the things in Ruby that we're good at changing, and what are the things in Ruby that we're not good at changing? I've been programming Ruby basically since I became a professional software engineer, and I suspect, like a lot of you, you really enjoy being here, writing Ruby, working in it every day. It's a really, really nice programming language to work in, and most of us love it. Matt's, created Ruby to make programmers happy, and I think to some degree he's succeeded at that. But there's more to it than just working in Ruby is nice. It's also to do with the kind of work that you can do if you're a Ruby developer. So as a Ruby developer, I've worked on healthcare, children's books, dating applications, and now at DigitalOcean, the internet itself. These are wildly, wildly different domains. They don't look anything like each other, but I'm able to be effective at them. And the reason for that, I think at least partially, is that the Rails convention over configuration mindset gives us a really powerful set of tools and set of moves to be accessible to applications in order to understand what they're doing. So when I walk up to a new application, I'm going to open the routes file. Sorry, that should be routes file. This is America. And ask the application what it can do. The routes file gives me access to all of its capabilities that my application has. If I'm interested in any specific one, I can pop open a controller to understand in more detail what the implementation does and then go all the way down to the models. But by having some Rails expertise, I'm able to very quickly understand a new domain of an application because of this standard cross-cutting layout of how we build our Rails applications. If I wanted to start a new software as a service application today, a familiar set of moves would kick in. I'd type Rails new and breathe an application into life. I'd bang out a bunch of scaffolds, and those would give me all the basic functionality of my application that I needed. And then I'd throw in some of the common gems, devise, Redis, styling, etc. And really, in all that time, I would have another software as a service application come out the other side that is functional and ready and actually is helping me produce useful software. And I think we have to applaud Rails for how quickly it enables us to build really, really great, useful software that can actually improve people's lives. There isn't another framework that lets you throw out software as quickly as Rails does, and that's amazing. We have this mentality in the Ruby community of how we develop software. We have a set of norms and idioms that we have come to that we really like. And that's not a unique property. Every programming language, every ecosystem, every community comes up with their own norms and idioms, but I think it's worth exploring ours. So, I recently had to build a new Rails application at DigitalOcean, and after a few hours of working on it, this is the actual code of a controller that I had in production. The thing that's worth noting is that apart from a single line, this is exactly the same as the Rails scaffolded template. I didn't even take the comments that Rails auto-generates out. It literally is line for line the same code. I added a before action to validate and authorize that you're allowed to actually access this controller, but it's just staggering and important to me to understand that I didn't have to write any code at all to provide useful business value at the company, and that's a kind of amazing thing that Rails gives us. Now, I would be lying to you if I said all Rails applications look like this. Some of them more often look like this. It's a mess of unpacking parameters, creating objects, touching the database, doing all the things you're not supposed to do. Now, I've been programming Ruby for quite a while. Some people might even call me an expert. And so I have strongly formed opinions about how I would go ahead and refactor this controller. And I suspect everyone in the room knows that this code should be refactored. Someone should do something about this. If you're a newer developer, you may not yet have fully, strongly formed opinions about how to actually go and refactor this. But fortunately, our community kicks in again and will help you. We have talks by people like Ben Orenstein and Katrina Owen and Sandy Metz, who I think it's safe to say is the queen of object-oriented programming, to help us get out of these holes. We have books written by sort of the same groups of people in order for us to dive deeper into those subjects. And the point is this: our community deeply values learning. I think nowhere is it more obvious that we have this sort of learning value, this refactoring mentality than in our boot camps. When new developers come into the Ruby community, basically the very first thing they are told to do is you must always TDD all your code. Now, I'm standing on stage as an RSpec maintainer, and I will tell you that I don't always TDD my code. I, in fact, mostly don't TDD my code. Apparently that's worthy of a round of applause? Question mark? But there's a reason for that. I have developed subtle, nuanced feelings about how to use TDD as a tool. When you're a beginner developer, you don't have subtle, nuanced feelings. You don't actually even have a reference frame from which to understand whether or not a thing is useful. Everything is terrifying. Syntax is terrifying. The semantics of Ruby and what it does is ridiculous. And so what we give to you is effectively this thing that if you always do it, you can eventually get to functional software, and it lets you move small and quickly and easily. And whilst it's not perfect, there is a reason we give this to our newest developers and help them on board into our community. We deeply care about software quality. We've had a number of talks at this conference about proposed methods for improving the structure and refactoring of your Rails applications. And whilst we don't do it all the time, I think we're pretty good at making the claim that we care, even though some of you, I'm sure, have built Rails applications that you are not proud of. So, the point I'm sort of coming to is this. The ideal Rails application is a well-factored monolith. It's a piece of software that's entirely contained, that talks to a database, that is mostly pleasant to work on and hews to the Rails way where it makes sense and deviates from it where necessary. By doing this, by taking these subtle set of actions, you end up on a place where, for the most part, you can be extremely productive. And that's an incredibly valuable thing, but it's not the only thing. Like, when we talk about the ideal Rails application being a well-factored monolith, I think the next question we have to ask is, well, who does that suit? Like, where did this idea come from? Where did we decide that, like, we want to refactor and build out objects but stay within the confines of a Rails application? Well, if you think about where Ruby comes from, it comes out of this, like, tiny, tiny company, plucky project management company, right on the left-hand side of this curve, a very, very small company. And it's generally true that the larger a company is in terms of employees or revenue or whatever you like to pick, there are fewer companies of that size. The world can't support 1,000 businesses of the size of Google doing exactly what Google does, but the world can support 1,000 companies of the size of like a Basecamp doing things that are very similar to what Basecamp does. And so what that means is that most companies that are using Ruby on Rails are small. They have small engineering teams, small number of employees working on generally smaller revenue systems. And the thing is, because when Ruby started Rails started 10 years ago, it was just like hobbyists and tinkerers, and then small companies began to adopt it because it's fast to iterate on and amazing to build and experiment and go quickly. And so if you think about who our ecosystem is for, I would posit that we implicitly created an ecosystem that is great for smaller engineering teams. And I'm explicitly not going to give an exact size, but somewhere in the 50 to 500 range is where we begin to encounter problems. And we're beginning to see this, right? When people say Ruby is dead or Rails isn't cool anymore, what they're really saying is, I no longer feel that Rails appropriately fits my context. Or they're just trolling, hack and use is a thing. But the point is this, we have companies now that have survived, have gotten out past this edge of the small company size. Companies like GitHub, Shopify, other examples. I have another one, I just can't remember what it is. And when you talk to people at those companies, they are feeling a lot of pain. You have hour-long deploy queues. You have crazy production bugs that you can't really replicate anywhere else. You have all sorts of interesting problems. And this idea that I want to sort of ruminate on is, what can we do to make Ruby appealing to people who work in companies of that size? Because I think we've heard how we're going to build Python or Go microservices at this conference now in order to scale our Rails apps. Well, that's one solution, but I would love to sit and think about what the Ruby solution might look like instead. And to do so, I sort of conducted a thought experiment, which is if Ruby was created by one person to make programmers really happy, and Rails was created by one person to ship products as quickly as possible, then that's a inherently small context where this thing is birthed from. Well, there are programming languages and ecosystems that are created and birthed in the literal opposite context, created by giant companies to solve giant engineering problems that really none of us could ever dream of. And so I looked to Google, and of course, that means we now have to talk about the Go programming language. However, I'm not trying to say that we have Google's problems. We absolutely don't. Not only is Google bigger than any individual engineering organization represented here, I would be willing to bet it's bigger than the sum of all of the engineering organizations represented. The number of engineers they have is truly ridiculous, and it's worth just understanding that we don't have their problems, but by considering what their problems are and what our problems are and trying to meet in the middle, we might be able to come up with something interesting. To understand where the Go programming language came from, you sort of have to go to the original early keynotes that were being given sort of just before the language came out, because the ones that happened after are very much more hyped and fanfare-y than these ones. And so you sort of come to this quote from Rob Pike and these set of ideas that he has, where basically Google hires primarily thousands and thousands of college graduates a year as their bulk of their hiring of engineering staff. Well, imagine taking a fresh college graduate and handing them a global scale problem and saying, good luck, go build this service. By the way, you'll be consuming services from all these teams all over the world, none of which you will ever talk to. Have fun. And the language that you're using is C++, a notoriously crash-resistant, reliable, and functional programming language. Not a great idea. And so the conception of the Go programming language comes from this idea that we want to be able to take wildly inexperienced programmers and have them tackle global scale problems in a way that is reliable and makes sense and is easy to understand. And that's a really interesting proposition. And from that, a bunch of really interesting philosophical points come out. One of the big ones is that machine communication scales better than human communication. And here I don't mean web requests are faster than mailing paper to someone. That's ridiculous. But it's things about documentation, about how you describe what a service does, about how you deal with errors, about many, many of these different concepts. And I wanted to dig into just a few. So one concept that Go introduces that we just do not have in Ruby is this idea of forced error handling. When you write a Go program, errors are inlined and you're forced to deal with them by the compiler. More specifically, if we think about Ruby, we're kind of a happy path-obsessed ecosystem. We write our software assuming everything that we do will succeed, and while that's a noble goal, computers don't work, and it's important to realize and understand that. How many of you have some kind of error tracking framework installed in your application? Sentry, Airbrake, Rollbar. In fact, we have someone from Honeybadger here at the conference, right? People make money off our inability to correctly deal with errors. And that's worth thinking about. Specifically in computer, when stuff fails, it generally happens because the network is down, the disks have exploded, that server over there is just literally on fire. We actually had that joke earlier. DigitalOcean has data centers, and I do believe that has happened. So, any operation can fail. If you look at the source code of a Go program, you'll see basically every function call returns two values. One is the one you actually want, and one is a potential error. If you highlight them, you can see that basically every single line of code in this function has something to do with dealing with errors. This is a radically different idea. And to bring it back to Ruby, in order for me to understand how code can explode, I have to go read a bunch of documentation, understand what exception classes can come out, and deal with all of that. To take an example from Faraday, let's say that I'm trying to just retrieve a URL and I've wrapped it in this sort of dummy HTTP client. Well, if I hit that URL, this method can fail with any of a variety of Faraday client errors. In order to know that, I had to go into the Faraday docs and search through their class hierarchy to find the base exception type. This error handling is also unforced. If I just forget to rescue this, my Sentry account's gonna start filling up with loads of exceptions every time XKCD is down, which probably never happens, but here we are. So let's consider, can we actually force Ruby developers to consider error handling as part of their day jobs? Well, yes we can. It looks like this. Instead of directly just dealing with the value, we've now wrapped Faraday in this sort of fake client, which forces you to pass an on-success and on-failure proc. I really like this design. I actually use this design a lot within DigitalOcean for operations that can fail because it removes rescues, it looks a little bit like JavaScript, but I'm literally forced to say on failure, do this thing. The program will explode with an incorrect arguments error if I don't, and I like this a lot. It solves the problem, it forces me to handle the errors, and to anyone who comes and sees this library, like it's right there inline in the documentation that that's what they have to do. Let's talk about gRPC. gRPC is a protocol library developed by Google that forces you to declare the schema of requests and responses between two systems. It looks like this. So you say, I have a service, it responds to this method, this is the input type, and this is the output type. This is much nicer than JSON by like a lot. I don't have to guess what the keys and values in my system are. Like, the program will literally refuse to send a payload onto the wire if it's incorrect, and the receiving service will literally refuse to deal with a payload if it's malformed. This is much, much nicer, and instead of me having to write a giant pile of documentation on what my JSON schema is, I can just compile a client and server out, and that's kind of great. Who here has spent far too much time building contract testing between services? This is a real problem when you get to a scale where you're not just building a single Rails app, you're building dozens of Rails apps, and they're all flinging JSON at each other, and it's like, how on earth do we test this? It's a giant nightmare. And then the worst one is I have to spin up my entire stack to test anything. Having a library which compiles out your responses is a really interesting solution to this problem. And the final one that I wanted to talk about is context. Context is a package in Go which basically allows you to accumulate state that is unrelated to business logic as it flows through your application. Things like user IDs, request IDs, typing information, timing information, cancellations, like all kinds of stuff. And then you can reconstitute that information like far away from where the request comes into your service. Context also can be passed across services in Go, which is really, really interesting because it then allows you to be like, well, this request came into this service, bounced over here, bounced over there, and now I'm dealing with it. If you look at a Go program, context is basically the first argument to every operation, and again, it's sort of all over the source code. The point I'm trying to make here is Rails logs very, very quickly become an unreadable, unmanageable mess. If you've ever tried to work out like a user ID, request ID, and timing information on a randomly logged active record query in your production logs, you know what I'm talking about. Which request caused this call? Did this third-party service get invoked? Like, these are hard questions to answer in Ruby right now, but they're essential if you're going to smash your monolith and like optimize for a bigger engineering organization. So this is a like pithy, badly written version of Conway's law, but basically, I have been thinking a lot recently about like what's gonna happen to Ruby. It's an interesting question to me, and I sort of see two paths. The one that we're currently on is Rails and Ruby continue to be an excellent, world-class set of frameworks, tools, and systems to quickly experiment, get something out the door as fast as possible, and then like move along from there. But that's not actually what the community is anymore. We are not anymore a group of people doing plucky startups. There are big, real, serious businesses that are using Ruby on Rails today, and that's a radically different context to the one that Rails was created in. And so the second path that I see is that we sort of change the way we think about our ecosystem to be more service-oriented, more designed for those larger engineering teams where working on a monolith breaks down because you have 500 people and you can't possibly like simultaneously deploy all that code to a monolith. It just doesn't make sense. And I guess the sort of dilemma is where do we go from here and what does Ruby become? Thank you.